Hello, today we will be investigating the longest jump rope swing available that we saw on a video. We are going to be assuming that the man is 80 kilograms. Since the rope swing was approximately 130 feet long, and there are 10 feet till the bottom of the ground. 130 feet converted to meters is 39.624, and the 10 feet is 3.048. Now to begin, solving for velocity, we use the change in E is equal to work. From there, we were able to turn it into a change in potential energy plus change in kinetic energy equals 0 because no work is being done. We solved for the final of the potential and the kinetic, setting that equal to 0. And from there, we were able to derive that mass times gravity times height is equal to the potential, and 1/2 mv squared is equal to the kinetic energy. From that, we continued plugging in the numbers we had, and we found that the velocity is 27.8681 meters. As for the bottom force, we were able to use the equation F net equals F tension plus F grav. Net force is equal to the force parallel plus the force perpendicular. The force parallel is 0. We're solving for the force of tension, so we're setting equal to the force perpendicular minus the force of gravity. From those forces, we were able to derive that mv squared over r minus mg equals the force of tension. From there, we plugged in our given values, and we got the force of tension to equal 2,352 newtons. And now we will be measuring the distance of the height of the rope swing from the top of the swing and at the angle 30 degrees. So since we know that the angle is 30 degrees on the inside, we were able to determine that on the outside it's 60 degrees. So from there, we use the sine of 60 is equal to the height divided by the total length of the rope, which is 39.624, and we got 34.3154 at 30 degrees. Then we took the total length of the rope and minused it from that value we just received to find the length of the rope that it would be minus its original length at the bottom. Then to find the distance that would be off the ground, we added the distance that it would be 3.048, which is 10 feet, because it's never going to hit the ground, plus the distance that we just found in part B. Now we will be solving for the velocity of this person at that angle, 30. So the velocity is going to be found by using the change in energy is equal to work, a principle we used in previous problems. The change in potential energy plus the change in kinetic energy is going to be equal to 0 once again. And we're setting the potential final plus the kinetic final is equal to the potential initial plus the kinetic initial. From there, we can learn that all the equations have m in them, so you can cancel the masses of the situation out. And from there, you plug in your numbers, and you will get 25.9342 meters per second. Also, at the angle 30, we want to know the tension of the rope swing and the tension of the force. So we're going to set the F net is equal to the force of tension plus the force of gravity. Force parallel is once again equal to 0, and we're going to set the equation equal to the force of tension. Force perpendicular is mv squared over r, and the force gravity, since it's being at an angle, you have to do minus mass times gravity times cosine of 30. Now you're going to put your numbers in, and you will find our force of tension equals 2,036.89 newtons. For the final part, we want to know how much our string will stretch. I gave my spring constant a value of 10,000. We want to find the stretch that it will have at the bottom of the rope swing. So to do that, I use the equation, the force of tension is equal to the spring constant times the distance. So I set the force of tension that I previously got in the bottom force, which is over here, which is 2,352, and I set it equal to the 10,000, and we got the distance moved would be 0.2352 meters. We also wanted to find the force of the length that it stretched at 30 degrees, so once again we plugged in the value of the force that I found in the bottom of tension, which is right there, 2,036.89, and I once again set it equal in that equation and found that the distance moved would be 0.203689 meters. We will be running our last simulation in VPython. We're going to try and stop the simulation when it comes midway through so that we can get a velocity similar to that of which we calculated. And our answer is 27, which is pretty close to our actual exact.